Hello guys, welcome to another episode of Sound Talk Show. We're going to do Wolfram Language Coding Advent of Code 2024 Day 3. Okay, I'm a few minutes early. So I'm gonna begin. If you are here, say hi. If you are watching offline, skip around and play at 1.5 speed because I ramble a lot. So Advent of Code, Wolfram Language Day 3, 2024. Okay, let's begin reading the problem. So let's put this here. So Wolfram language, let's make a new notebook. New notebook 3, launch the kernel, and advent of code number 3. Okay. So let's see. Let's just skip right down to the problem. Oh, there's no input. Usually there's a block of input, but there's none here. Okay, so you gotta read it. Day 3, more and over. Our computers are having issues, so I have no idea if we have any chief historians in stock. You are welcome to check the warehouse, though, says the mildly flustered shopkeeper at the North Pole toboggan rental shop. The historian head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? The computer appears to be trying to run a program, but its memory, your puzzle input, is corrupted. All of the instructions have been jumbled up. So memory is corrupted, okay? It seems like the goal of the program is just to multiply some numbers. That's a goal. It does that with instructions like mo xy, where x and y are each 1, 2, 3 digit numbers. Okay, 1, 2, 3 digit numbers. Mo xy. Okay, that's an important part. For instance, more 44, 46 multiplies 44 by 46 to get a result of 2024. Similarly, multiply that would be multiply that by that. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of the multiplication instruction. Sequences like mo 4 star, mo 4, 9 ban, question something, or more something, do nothing. Okay, so you gotta check basically. So you have to check the syntax, that's the input. Okay, for example, consider the following section of corrupt memory. So okay, so that seems, so we got this line. Okay, so only the four highlighted sections are real multiplication instructions. Okay, so that's that, and do not more that. Okay, then that. Okay, so that's like 4 of them. Adding up the result of each instruction procedure is 161. Okay. Scan the corrupted memory for uncorrupted multiplication instructions. What do you get if you add up all of the results? Okay, so it's some kind of parsing problem. It's not exactly parsing. It just, well, it's called parsing. So let's see. So part 1, let's begin Wolfram language part 1. Okay, x variable x input equals to that. Okay, so what you want is, so you want to grab, let's see, yeah, okay, so this is Wolfram language. You want to grab something like that. Let's see, what is the valid input? So let's write out the valid input. So the valid input will contain the word more for sure. Okay, so let's highlight it. So you can see so we can actually just split by more, then needs to be followed by a paren digit comma then closing paren. Okay, so these are the 2 4 5 5 11 8 8 5 2 4 5 5 11 8 8 5. Okay, so you just need to extract this. So simple. This is a regular expression. Are you sure? Yeah, I think I'm pretty sure. Okay, valid ones. Okay, so some comments. So let's begin regular expression. Okay, so you want regular expression. I can do this in Emacs, Perl, Python, Ruby, JavaScript, but I can also do it in Wolfram. But Wolfram, I forgot. Wolfram language has regular expression in the traditional syntax. If you don't know, go to search for Kazaa Wolfram language tutorial, and you can click on download. It's free, and you have the full tutorial from the ground up. So we want to go to regular expressions. Okay, so let's see. Basics, common, print, string, regular expression. Okay, so Wolfram language supports a traditional regular expression syntax, but it also supports its own syntax called string expressions, which is actually easier to read. So we want to do regular expression. We want to pass. Okay, so this is a string, right? So yeah, let's make it string. No wonder, that's why I was wondering why no color. Okay, so you got a string of you want to pass it. So the question is which function you want. You want string cases. Okay, if you can find, my tutorial has string functions and the regular expression. Let's see, string functions, string replace regular expressions, string expression pattern syntax. Okay, so you got all kind of string functions there. But anyway, the one we want is string cases. Okay, basically that will extract the patterns you want. So go to Wolfram language documentation. Okay, the network is slow. Am I like healthy? Okay, something is fucked. Wait, it should be good, but am I good, guys? Hello, GCS. So am I streaming okay? Okay, so this is string cases, string and pattern. Okay, so we want right, so what we want is we want to so string cases take two input. The first one is a string, the second one is a pattern. So the pattern, let's just say let's give it a regular expression. Okay, and so the regular expression, what we want is let's see, the regular expression is gonna be more than a digit. A digit is \d, then plus for one or more, then another digit. Okay, and in fact you need to capture the digit. So okay, so we need to look up the regular expression syntax. There it is. That's the function. Capture. Okay, so the digit is \d. Okay, so but how do you capture? Usually it's paren, but do you require backslash string matching the sequence. Okay, so yeah, well, let's look at my own documentation. String expression. Say hi. Okay, so string, so we regular expression. Okay, insert into string, delete substring. What are we doing here? We want string functions, we want regular expressions. Okay, so let's just go to regular expressions. So there it is, and example string cases. Okay, yeah, so now replace string by captured patterns. Okay, we don't want to do that. We want okay, so I don't have the documentation for the Wolfram language. Well, there it is. Capture. Okay, so where is the capture? Maybe we can just try it. Okay, so actually just run it. Trial and error coding. Okay, empty. Well, that's because that's a capture. Is that right? Run it. Empty. No, that's not good. Let's try something simpler. Okay, some thing. Okay, so now regular expression is just gonna be digit, sequence of digit. Run it. Okay, we got it. So that's digit. Now if we do it with a paren, would it capture? Run it. Yes, so parenthesis is capture. So now why is this line not working? Digit is slash paren is capture. Okay, so mul input. Okay, so I don't understand why is that not working. So we gotta put that here. Run it. Empty. Why is that? Is it because the backslash? I hope it's not like Emacs. Yeah, fuck, it's like Emacs. Well, you see, this is interesting because in Emacs Lisp, when you have a regular expression is represented as a string data type. So there is no special string to represent regular expression, such as in Perl, in JavaScript, in Python even. So in these languages, Perl, JavaScript, Python, they have a normal string. Then they have a string for regular expression, so that you don't have to have like backslash toothpick syndrome, this is called. But in Wolfram language and Emacs, this Wolfram language is a Lisp. So including Scheme Lisp and Common Lisp, they don't have like two strings, one for regular expression. They only have one string data type. So in this one string data type, the backslash is escape. So when you want a backslash in a regular expression, you have to have two backslash. So these two backslash there represent one backslash, and that, then you have paren, which is to escape the paren, because otherwise parenthesis means capture. Okay, so we want a literal left parenthesis here. Then we want a capture. We want capture the D here, and we want also capture the D here. Okay, so let's do it. okay, it returns the whole thing. How can I just return the captures? Let's just get it to work. Okay, so here is the output. So far so good. So so let's just make it work. X2 equals to that. Then all we have to do is just let's do more parsing, one more parsing again. So you just get all numbers. Okay, something like x3, then here is x2, then all you want is just numbers. Okay, let's see what it get. You need to remove the semicolon because semicolon suppresses the outputs. Okay, so you got that. Then you just turn that into a two expression. Okay, that is like string to number in other languages. Okay, so you got a real list of numbers. Okay, then you just all you have to do is just multiply and sum. Okay, so times, you want to map the times function. So that's /add is a shortcut for map. So you map the time function to x3. Let's see. Let's test. No, I don't think that's. No, that's not. So you want to yeah, okay. Let me show you trick. Trick things like that. You wouldn't understand. Okay, so, then that's it. Then just total that. Okay, run it. 161, is that the correct answer? Answer for toy input. So is that correct? Let's check. 161, correct in one shot. Fantastic. What's going on? Okay, so here's our solution. Let's remove the testing code. So it should I? Well, test run. Okay, so this is a test run, and now we're gonna do a real code here. So real code, we don't need all these comment, so we can simplify it much. So this is x2 occur there. Well, okay, let's leave it. Okay, and this line, you can the more formal way to write it is, let me show you. Okay, so the more formal way to write it is map. So map x3 and map a function, and this function is gonna be times. In fact, apply times to the x. So this is actually the same. So this line and this line is the same. We can run it and see. Okay, you have to remove that. 161, you see, correct. Okay, Okay. Okay, so that's that. So that's the day one solution. Okay. Oh yeah, so you need to get your own input showing browser. So today, this is our code. My own input, get your personal input. Okay, big, humongous crap. Okay, so let's save that. So this is my advent of code for 2024 index page. We did yesterday's, and so let's go to advanced. So I have it here, new, save xxx. Okay, and go to diet and rename this to advent of code day 3. Okay, open it. Oh, that's okay. So some lines are big. Wait, okay, they also include line returns. Interesting. Okay, so anyway, get it, close. Yeah, so that's today. So we're gonna continue do this. So we need to, now this is a URL, actually this is a file. Read string. Okay, read string input equals to read string, this string. Open it then. Okay, that's good. So we read the string, then do the same before. Is that right? So let's think about, should be, but let's look at the so this is actually a problem testing your regular expression skills. There it is. Okay, we remember we have a day 2, part 2 problem. So let's quickly get this done. Submit. Yeah, that's the right answer, of course. Let's continue to part 2. Okay, part 2, can you see it? No, actually you okay, so fantastic. Okay, showing browser. That's our code today. There. So let's get on to part 2. Break, drink. Am I doing good? Okay, part 2. You scan through the corrupted memory, you notice that some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statements in a program, you might be able to get an even more accurate result. Okay, there are 2 new instructions you'll need to handle. The do parenthesis instruction enables future multiplication instructions. The don't instruction disables future multiplication instructions. Only the most recent do or don't instructions apply. So at the beginning of the program, multiplication instructions are enabled. For example, that one, for example, okay, here it says, so you got a multiplication there, then you got a don't. So that means disable that one. Okay, but then when you have a don't, it disables future multiplication. Okay, it disables them all until you reach your do, something like that. So this corrupted memory is similar to the example from before, but this time the multiplication 5, 5 and 11, 8 instructions are disabled, okay, there, because there is a don't instruction before them, okay. Once you see a don't, it disable all until you reach a do. The other multiplication instructions function normally, including the ones at the end that gets re-enabled by do, okay. This time the sum of the result is 48, okay. Okay, so when you see a don't, okay, yeah, the part 1 is easy, trivial, but the part 2 is do and don't. So yeah, am I gonna code it? Yes, I suppose so. Let's do it then. Where is it? Okay, so copy it, part 2, okay. So actually you have a new test input, okay, copy. Now I believe this one is different from you see, you want to highlight don't. Let's see, highlight do. Wait. Okay, and don't. Okay, so we got don't and do highlighted. Okay, and then if we open this file, let's do the highlighting too. Okay, so it kind of look like that. Each line is kind of long. Then also highlight don't by pink. Okay. Okay, so now yeah, I forgot, I've lost my color anyway. Okay, so what you can do is you split you want to split for each line. Wait, are they line based, or is this just one whole single line? It's supposed to be one whole single line. Because it matters, because let's say you have a line and the last item is don't. Then you have a next line. Do you consider starting afresh, or is it still don't? So the question is, do you consider the input, the whole, as one single blob? Or in other words, does the don't continue to the next line? So does it say the don't instructions disable further multiplication instructions, so they didn't mention anything about lines. So I suppose you can consider it as one single huge line. Okay, so what about what is your approach? Well, we can read the whole thing. So this is a new input. Okay, so this is a new input, and the input is different. The toy input is different, but the user input is still the same. So you can read the whole thing, and you can split by a regular expression. Okay, what? Not input. Pattern. Okay. Okay, so we need to think about this actually. Let's show space. So whenever you see a don't, so let's see highlight do. So does it continue over the line? You see here's important. Don't and do. Okay. Okay, let's just do it. Okay. Okay, split string. Regular expression, and we have don't, and we have vertical bar or do. Okay, so now, so you need slash backslash backslash to represent a literal parenthesis. So you split by that, and okay, so the answer for toy input is 48. Okay, so let's see what we get. Okay, so this is a huge string. Okay, this is hard to like debug. So you got don't and do, okay. So you got a bunch of don't and do, okay. So split. So anything between don't and do, you can kind of remove. Does that work? Does that logic work? So whenever you see text between don't and do, you can just remove it. Then just do the normal one, like the part one. I think so. Yep. So here, but over here you need to also need let's test. Okay, so whenever you have an issue, you can just say something test TT or XX. So we want grab XX or TT. Okay, run this line. That didn't work. So the odd sign is special. No, that didn't work. Oh wait, so let's say T9 H8 M. Okay, let's do this. A B C A B B C C. So 8 and 9. So we want to split by either number 8 or number 9. Okay, run it. That worked. Okay, so that means the vertical bar is a alternative syntax. You don't need backslash. Okay, so we got that figured out. So that means we don't need that. So okay, so let's put it here, and so we take the input and regular expression, and so don't, let's make sure these don't, stupid don't. Yeah, let's just run it. Okay, so we got it's annoying because the original input already have line breaks. So let's do some string replacement. Okay, regular expressions. Let's go to string functions. String functions. Is string length join string. We want to delete substring. Not by character. Okay, so we want string delete. Okay. So string delete string and pattern. Okay, so the string is X input and the pattern is gonna be just that. Okay, run it. So now this should be one giant single line. That's what we want. Okay, so this will be named x2 equals to, okay, one giant single line. Then so this is for testing code. Let's put the test code there. So then we do this. Okay, then okay, run it. Now each line will start with a do or don't. Let's see. Yeah, okay, so well, it's hard to read there, so let's try the Wolfram language notepad. Oh, that's right. When you remove that, you also remove the do and don't. Let's do something more. Okay, so x2 equals to string delete. String delete can take a list to do multiple deletions. And let's do some string replace, because the do and don't is kind of complicated. So string trim, string drop, string get substring, convert, format, string match, string replace. Okay, string replace parts. Yep. Okay, so we want the string is X input. We want what is it? Replace string by position range. No. Oh yeah, so string replace, not part. So string replace, which is replaced by pattern. Okay, copy that. Okay, some dogs X input. Then we got you can then you need a regular expression. Okay, so let's see. Okay, regular expression. First of all, let's just replace empty line. First of all, do that. Then we want extra replacement. Then don't replace by something like that. Okay, Okay, so search for NNN doesn't occur. Search for NNN does not occur. Search for YYY does not occur. That's good. So if we do that, then yeah. Okay, let's look up the documentation for string split, because string split will, because we need to keep the don't. Yeah, so there it is. Fantastic. Okay, so we got a new this power of Wolfram language. So instead of 2 here, the second part is gonna be a list. Okay, then the list is gonna be 1 to 2 items. The first item we don't even need regular expression. Okay, so the first item is just don't. It's simple. Okay, the second part is just do. Okay, so you got a list, so this is much simpler. And then when you replace, you actually want to turn it just no. Okay, then here also replace yeah. Okay, so there it is, simple, so we don't need that. Yeah, so and we don't need this elaborate replacement either. So it's just that. Okay, remove that. Let's put it back. That's the backup code. Okay, so now string replace the new line by empty, make it one single line. Then this you don't need that neither. Then just okay, then do it. Okay, so now every time you see yes, oh, okay, so yes becomes a new entry. Okay, so no. So basically you want to remove, so basically the problem becomes, if you have a list, let's say 1 2 3, let's say whenever you have a no for whatever number and yes whatever number, so when you have a list like that, you want to remove any sequence that's followed by no to yes. Can you do that? Yes. Yeah, okay. So, well, that can be easily done by pattern matching. So we can say x3 replace all x3 a pattern anything yeah, this is not efficient. Maybe we stick with strings. Okay, actually do the string replace. Okay, some kind of do the string replace. Okay, string replace, also take a list as a second argument. Yes, so the second argument is going to be oh God. Okay, this is not. No, that doesn't work neither. Shit. How am I doing? 2 people watching. Okay, so okay, work on this problem. Yeah, let's get me some water. Okay, so split is a good solution. Okay, so but when you split, you get a situation like that, and maybe we just do with the pattern matching. Okay, 0 or more and 0 or more. And how do you, so this is the thing. Okay, partition. Okay, I kind of know what I want, but the issue is how do you do this? Now let's think about string. If you do it string, you got the nasty issue of regular expression because you want a don't, you want all characters after the don't and delete them. You want any character after the don't, then delete them. But the problem is if you use regular expression, yeah, so the problem is very simple. You just use regular expression and you want to remove anything between don't and do. That's right. You just remove anything between don't and do. Okay, and but to do that, you have to, yeah, you can do that. You can just, use a dot plus yeah, you can do that, I think. Yeah, maybe it's just a simple regular expression thing. Maybe. So whenever you see that, just remove it. Okay. So this expression, just simply remove these do and don't. Crap. Okay, so just there, string replace. Anytime you see don't followed by one or more, maximum match, and until you see a do, just replace it. Run it. Okay, so search for do. You still have do, of course. Wait, but you still have don't. No, because then you'd what? Oh, okay, so this needs to be x2. This needs to be x3. Run it. Should be one single line. That's right. Oh, now it's much simpler. Let's see. Highlight, don't, yellow. No, one occurrence. Highlight, do, pink. Okay, then all you have to do, so you removed all the between don't and do, but you need one last do. Yeah, let's just append one last do. What is string join, string append, string functions, convert, format, string match, string replace. Okay, string functions, string escape, string functions, length join, string join. Yeah, we can do that. String join that, then just add a do. Okay. That's right. Then you just do this. Run it. Okay, that's the output. Now highlight. Let's highlight. Copy. Let's highlight do. Yellow. Let's highlight don't. Pink. There it is. So now you just do as before. So now you just do the same solution we did before, like part 1. Copy. Okay, I believe, close that. I believe that's it. So wait, so let's clean up a little bit. So this is gonna be the new input. Let's clean up here. What? Let's say part 1 function. Yeah. Yeah, there. Okay, I think that's it. So we got y2, then y3. You know, the x2, x3 is just same as before. Then we got x3. Then, yeah, I think that's it. Okay, shall we run the code? Let's, first of all, the 48, I think. 8. Incorrect. Yeah, it should be 48, but we got 8. So that's incorrect. So let's remember, remove don't to do. Don't to do. So remove don't to do. Remove don't to do. So what is this? So it should be 24A5. 24A5. So it's 48. Why are we getting 8? So we got 24 for sure, probably, but we don't have A5. Okay, so time to check what is the what is x2? Okay, now what is the y3? Okay, so something got cut off. The A5 got cut off. Why is that? Oh, because yeah, so your algorithm is wrong. So I mean, because of the special edge case, because of that. So you don't. Yeah, so that is the tricky part. That's the design of this problem tricky part. It's about the edge case off by 1 problem. So basically, so you want to remove all the don'ts between don't and do. Okay, so once you do that, you might also have some don'ts. You might also have some don't that does not have do at the end. So let's not append. For example, if we don't do that. Okay, so run it. 48, you see, so, but that means, but it won't work when you have, you see, that's tricky because the example doesn't show this issue. It won't work if you have, actually it may work. Let's just run it, okay? Let's just run it on the personal problem, personal input, because fuck the advent of code. Because if you think too much, it's gonna punish you, okay? So let's try this. Let's just try without being super careful. You see, imagine this is a nuke button. If you cannot just, let's try out an error like the most programmer idiots. Because if you push the button, the answer is incorrect, somebody died. Suppose this is Mars mission, things like that. So, I mean, there's different type of programming, there's different levels or class of seriousness, how bug can be tolerated. For most industrial programming, like the web programming, the web idiots, the JavaScript or the Python, it doesn't matter. You can just try it. But for other issues, designing an engine or rocket, then you really have to be careful. But let's just try it. That's not the right answer, you see. Yeah, I know. So when you remove, when you remove the in between don't and do, what happens is that you may have a last sequence of don't that do not come with a do. Okay. Okay, so what you want to do is over here, then you add it. Then you add the do. Let's just say that. This is not functional programming because you are overriding the value. I don't like that. But let's just get it to run. So once you remove that, then you add the do. Then you run this again. Actually, it's fucking idiotic. Fuck. This, you see, this is not functional programming. You don't want that. Yeah, but let's just run it. Okay, did I get the same answer? I think that's what I get before. No, let's run again. What? I'm not sure. Toy input is still correct. Okay, but let's just try it. 1006589. 1006589. That's the same answer. No. Yeah, very close, very close. Let's see, what is y3? Two, 4, 8, 5. That's right. 2, 4, 8, 5. But let's see if we use that. Then here's the output. Copy it. New buffer. Close it. Reopen it. Text. Highlight the do's and don't. You see, we got the don't there. So, what does it say? The don't we should remove. No. So, okay. Yeah, the problem is, you see, it's a regular expression because this plus dot plus, it may cover actually many do's. Yeah, the regular expression, I don't think you can do that. Oh yeah, you can say minimal match. But we added a do. Why didn't we delete it? I don't understand. We added a do here. So there's two issues. One is that you need a minimal match. So normally that would be a question mark in normal regular expression syntax. Okay. Yeah, the shortest consistent string that match. So actually this should be a 0 or more, not plus. Very tricky fuck. And 0 or more. Don't, so there is one don't there. Search for do. There is do. Several. But for don't, there is just one don't. Okay, so there's one don't occurs there, and there is no do after that. Okay, so you need to remove that. so what you can do is don't append, because append is sloppy. You can just one or more maximum to the end of line, which is $sign. Okay, $sign means the end of string or line. Okay, yeah. So if we do that, evaluate. Okay, here's the output. Copy, new, paste, search for don't, no occurrence, search for do. Okay, but why is that? You see, before you got how many? 2,000, 10,000 characters. Okay, but with the don't appear at the bottom, don't how select what? Okay, but if you to replace that, oh wait, this is X, fuck, I'm idiotic. This should be X3. That's why it's wrong. That's why fucking I got a code error all this time. Search for don't. Okay, not to be found. Now 10,600 characters. Search for do. There's a lot. Okay, that's expected. But search for don't. There's none. Okay, so that is good. That is good. Then we just check the total. Okay, run it. Okay, now that's the answer. Hopefully that is the answer. This should be the answer. Do it. That is the right answer. Hello guys, solution correct. So here is the solution for part 2. Fantastic. That's 80 minutes. Yeah. Okay, thank you guys for watching. Good exercise. Nightberry, hee, thank you. Yeah, that's it for today. So all this while, we didn't make any major mistake. The mistake we made is just syntax errors. So we forgot about, the regular expression. Well, I mean, regular expression is tricky by itself, fairly tricky. So we forgot to use the, 0 or more instead of 1 or more. We should have 0 or more. Well, actually, I don't know if this matters. But anyway, the other big thing is that we didn't delete the last don't to the end. But I mean, the major mistake is that we are using our variable was wrong. This y2 and y3. We're supposed to update the y3, not using y2. So that was the mistake. But anyway, here's the code. Here's the final solution, and it can be simplified a lot. For example, these 2 lines can be combined to one single string replace. In fact, all these 3 can be done in one shot. Actually, let's try it, shall we? So all you have to do is change that into a list. So instead of 3 calls, you have list of 3 items. Okay, so that's one item. That's a second item. and that's the third item. Okay, I believe. Wait, why? So you don't need. Fuck, we fucked that up so much. So this is just Y3 directly. I think that'll work. So run it. No. Because they are not done sequentially. So anyway, yeah, but still, undo. Yeah, well, let's run it. Still, you can combine these 3 lines into one. But anyway, that's it for today. Thank you guys for watching. Put it back, color it, show in browser, and there we have it. Today's code. Bye. Oh, wolf. We got a wolf here. 9 berries, a wolf head.